Now let us see, when is data high dimensional and why might that be a problem? So we call data high dimensional when the number of features is very large compared to the number of observations. So for example, 1000 customers each described by 500 attributes, that is a high dimensional data sets. 100 images each with 10,000 pixel values, again it is highly dimensional. So why is this a problem? Exponential growth of space. As the number of features increases, the possible combinations of feature values grow exponentially. The model now needs to learn from a space so vast that data becomes sparse, making it harder to generalize. So, sparsity. Imagine points scattered in a high dimensional cube. The more dimensions you add, the further apart these points become. Sparse data provides less context for learning patterns. The model has too much room to roam and not enough examples to learn from. So distance metrics breakdown. Algorithms like k nearest neighbors, which means KNN algorithm, or cluster methods depend on measuring distances between data points, but in high dimensional spaces all distances tend to become nearly equal. So the concept of nearness or similarity loses its meaning. So this curse of dimensionality sounds like something straight out of a pirate movie, but when it really refers to is when your data has too many features. As a result of this, algorithms that perform well in low dimensions like clustering, regression or classification become unreliable when features multiply uncontrollably. So when we push data into many dimensions, three main issues arise. So overfitting, first one. Overfitting in the sense the data matches more than the expected one, and loss of distance and computational cost and irrelevant features. So in today's big data world, it can also refer to several other potential issues that arise when your data has a huge number of dimensions. We run the risk of massively overfitting our model. This would generally result in terrible out of sample performance. Too many dimensions causes every observation in your datasets to appear equidistant from all the others. If the distances are all approximately equal, then all the observations appear equally alike as well as equally different, and no meaningful clusters can be formed with that. So before going to the example, let us say what about overfitting and loss of distance meaning and computational cost and irrelevant features. Overfitting in the sense high dimensional models tend to memorize training data, even noise is also included, since the model has too many parameters relative to the number of samples. It becomes too flexible. It performs well on training data but fails on new or unseen data. Loss of distance meaning, in high dimensional space, the difference between the nearest and farthest neighbors becomes negligible. Mathematically, the ratio of the nearest neighbor's distance to the farthest neighbor's distance approaches 1. This means clustering, similarity detection, and a distance-based learning like KNN or K means clustering start to break down. Computation cost and relevant features. As the number of features grows, so does computation timing also. Many features might be redundant or irrelevant, but they still consume processing power and introduce noises. So, as a result of this, a model becomes heavy, slow, and inaccurate. It can't even distinguish signal from noise, and the underlying data structure becomes meaningless. So, these are all the problems caused by high dimensional data, and also it causes when we push the data into many dimensions. So, we will discuss about an example of a high dimensional data clustering hereafter.